Yep, we have
Yeah,
started recording.
yeah. Over to you, Shriva.
Okay, you can hide this tab, like this pop up. Okay,
Yeah, go ahead.
so yeah, so hi and good morning, everyone, to Mysore group. Okay, so welcome to MuleSoft Mysore Meetup group. So today we are having the topic handling non-functional requirements of the API through API custom API policy. So we'll be looking into that. So thanks everyone for joining. And before we continue with our presentation, so I'll read out some safe harbor statement. So both the speaker and the host are organizing this meetup in individual capacity only. We are not representing our companies here. Okay, and this presentation is strictly for learning purpose only and not meant for any promotional activities. Okay, let's move to the next slide. So we are recording this. Okay, so we'll be uploading this to our YouTube page and to the events page within 24 hours. So you can, if you want to rewatch it, you can do that. And so this is the part 2 of this. So part 1 we have already uploaded. I will share the link in a little bit. Okay, so all right, so we have two organizers for this, me and Giri. So Giri will join later. Okay, so I'll introduce myself. Like I'm working as a professional integration developer in Millennium, India. Okay, and Giri is working as a senior architect in Hasden. Okay, so you all guys know. So over to you, Vijay.
Yeah, yeah. Hello, everyone. Thanks for joining this call. And so, myself, Vijay Raghavan. I'm an integration architect in Ernst and Young GTS. I'm having like around almost 12 years of experience in integration and API products specific to solutioning and design. And I'm having like spanning across multiple integration products starting from MuleSoft, IBM Stack, and cloud technologies. And I'm being a MuleSoft mentor and active speaker in the MuleSoft community. And I have 6x certified in IBM and 2x certified in MuleSoft. So this is my quick introduction about. So and so we are going to see the session on the part two. So we had a prequel session to this one, so where we have covered first of all like what is a API non-functional requirement and how we are going to handle that, and how we are going to handle that using API out of the box policies. So we kind of discussed in detail in all the API policies which is available readily available in the your API manager, and how we can handle NFR using that. So those we had as a first session, and this is a follow-up session. So in this session we are going to talk in detail about the custom policy, so how you can utilize this custom policy in detail to that. So specific to this, we are also like before starting the custom policy, we are just going to have the summary of the session one. So what we have see in the part one session. Okay, so we're just gonna first talk about first 10 minutes about this one, and then we jump into the custom policies, how you can handle the custom policies and the structure and all these things, and then how you can develop, package, publish, and manage a custom policy through your API manager. And then we have one a small use case, like how you can create a custom policy, a kind of live demo, and followed with the Q&A. So let's start it out. So first of all, we have to understand what is API's non-functional requirements. So in any requirement gathering, so our foremost thing is to get the business requirement, okay, in order to get the details in place. So when you're talking about solutioning over integration layer, so we are most concerned about what would be our source system and what would be a backend system and what kind of data traffic that we are going to deal with that. So these sort of functional requirements, we go talk about like kind of orchestration, routing, all these things. Okay. uh, the non-functional requirement also is an essential part of your requirement gathering, and how we are going to handle that, it matters. So ideally, to put it in a nutshell, like what is an AP non-functional requirement is, we can put in a simple term that it tells that how your web API implementation should behave. Okay. And how your web API implementation should kind of guarded and performed in terms of API invocation is happening. So for instance, if a web API client is making a web API invocation to the web API implementation, then the non-functional requirement will define how that particular web API implementation will be managed, secured, and behave. So these sort of things comes under your non-functional requirement. So ideally we can categorize this in a high level nutshell, I would say. So where we can categorize this in terms of performance of your API, security, compliances, consistency, and reliability. So these are things we can kind of segments we can encapsulate to a non-functional requirement for an API implementation. And how do you handle the non-functional requirement? So it is not just with your API policy. There are other factors to be considered in order to accommodate this uh, handling this non-functional requirement. The first and foremost is, so which deployment model you're going into. Okay, so ideally you should be having some high performance runtime plane in order to maintain the scalability and reliability of your API. That ensures your performances are efficient in terms of your throughput processing time of your API. For example, cloud right, and which is highly scalable performance runtime plane. And also handling a non-functional requirement indicates how you're going to design your API. So when I say design your API, how you're going to implement it in terms of being a fault tolerant, like how will be how how you will be increasing the throughput of the API, like implementing a caching, persisting data model. So everything can be encapsulated in terms of API design as well. So apart from this thing, we have a specific categorization of handling non-functional requirement of an API through API policies. So API policies, kind of playing the major vital role, I would say, in terms of handling the non-functional requirement with respect to the security, compliances, and then quality of your service and the operations. So, for example, out-of-the-box policies and the custom policies. So when we talk about the out of the box policy, so out of the box policy, as the name indicates, which is a readily available functionality of a product. So these policies are readily available in your API, which you can go and utilize it in terms of securing, or in terms of making your API compliant, and in terms of making your API to be a high quality of service. So you can very well use this out of the box function API policies in order to secure that. So we'll just quickly have a glance of what all the out of the box policy we have in a list, and then we go to the custom policies. So the out of the box policy, we can segregate in terms of compliance, security, quality of service, message logging, and transformation. So compliance is a one where we have a two major policy, which is client ID enforcement, cross origin, and resource sharing. So this client ID enforcement is something which is going to enforce the client ID and client secret. This is specifically for the system to system authentication. So when I would say that it validates the compliance of the source system where it comes from. Okay, so for each client who registers to the API, okay, will be provided using this the client ID along with the client secret. So they have to pass it on through the web API invocation, and that would be validated within the API manager. So this client ID enforcement is part of compliance thing. And then the second one is cross origin and resource sharing. So this cross origin resource sharing is a very interesting API policy, I would call it out, because whenever there is an API call that is going to come from any of your web portals, right? So it is a browser based web portal, and that's where this particular cross policy has to be enforced, because uh, the browser will not allow because when a particular web page is loaded in a browser, it means the browser will consider the source origin as the wherever the particular web page is hosted. Okay, so it expects all the HTTP transaction from the browser to the web server should be within that origin. Okay, if there is a indication that that web server is going to make a call to another origin, for example, that web server having the code of making an API call to the MuleSoft layer, where the MuleSoft layer is lying in a different server. So it is a cross origin. So browser will not allow that. So for that, before allowing the server to make the API call to the MuleSoft layer, the browser will go and do the pre-flight call to the MuleSoft layer to check whether the cross origin is allowed. So this API policy is mandatory in terms of allowing the cross origin resource sharing when you are dealing with the web portals. And next important thing is security, and here we have a lot of varieties, I would call it out. So first we talk about this HTTP basic authentication API policies. So where we have, basic authentication of LDAP and the simple authentication. Simple is something only one user can do, that where you're just going to hot code your user ID and password, and this is not recommended highly for any of your actual implementation. Whereas if you have a LDAP setup available in your enterprise, you can go for the basic authentication where LDAP configuration can be done in order to authenticate the user. And next important thing is IP based API policies, which used to indicate IP block list or allow list. So what does it mean here is, uh, it will regulate the traffic to your API in order to restrict, like, who can come and who cannot come. So it's as simple as that. So IP block list is something that you can block a certain number of IPs in order to, for example, you have a 10 client, you want to block particular 5 client out of that. So you can use the IP block list in order to restrict the access to those particular 5 API clients. Whereas IP allow list, you can be very choosy in a way that you are going to allow to a particular set of client. For example, if you have a number of clients but you want to allow a particular API to be accessed only by 2 clients, so you can use IP allow list in order to regulate the traffic or restrict the transactions. And the next one is the payload threat protection API policies, which are we have JSON as well as XML thread protection. So ideally, the concept here, begin the scenario is like, the hackers can easily make your API unstable by making a payload attack. So when I say the payload attack, so they can bombard the API request by giving the undefined values in terms of the structure, as well as they can increase payload size, which will definitely make your API unstable. So that's where we can prevent those payload threat by applying these policies. So ideally what it is, let's take one scenario, JSON threat protection. So you have a JSON message as your request to your API as part of your API specification. So you can define how many number of objects should be presented within the structure, and what is the length of the what is the maximum length of the a JSON object, and what is the maximum length of the JSON value, and how many nested array can be presented within the structure, and how many maximum number of entries per object also can be like defined. The same way goes for XML as well. So you can very well define the length of your value and the elements, as well as the number of attributes and the nested arrays. Everything you can restrict using this policy. And the last one here is the OAuth 2.0 access token enforcement API policies, where we have OAuth 2.0 is something that we MuleSoft itself providing you the OAuth provider. So if you don't have any external OAuth provider, ideally most of the enterprise will go for the third party OAuth provider, like Ping Federate, OpenAM, or Okta, or OpenID Connect. So these kind of third party identity provider used for both user identification as well as the client identification. Apart from that, if you don't have a third party, well, MuleSoft by itself provides a OAuth provider by default, so which you can take care of generating a token, and then validating the token and creating a credential for the API client. So everything can be done using that. So these are the possibilities we have with the OAuth 2.0 policy. And then we also have a JSON Web Token Validation API policy in order to do the authentication authorization. And the next one is quality of service. So the quality of service is majorly we can talk about in terms of governance of your API, in terms of like how you can regulate the traffic, or how you can regulate the process to your API. Okay, so you have a number of clients, but if everyone start calling your API, that also makes your API unstable, or kind of loses reliability. So that's where you can apply all this quality of service API policies, where you can rate limit based on the SLA or non SLA. So when I say SLA, it is service level agreement specific to particular API client. For example, I have two API client. The first API client, I'm just telling them that that API client only can access my API like 100 requests per minute. Whereas the next API client, I'm restricting them to access only 50 requests per minute. So these are the SLA based rate limiting I can issue it using this policy specific to the API client. And I also have non-SLA based API policy. Like, I can set a general rate limiting policy, like, simply I would say that I would be accepting only 100 requests per minute, irrespective of how many number of clients I'm going to get. So this is going to commonly applied for all the API clients. So every API clients will have only 100 requests per minute to the API. And then the next one is spike control. So spike control is again which will ensure the number of message, and the number of message you config for the API, or number of limit you config for the API. Only that much, that set of messages would be processed at the time. And whatever the message that are exceed the threshold, that will sit in the queue. So this spike control policy ensures that it happens that way. And then the next one is HTTP caching. So HTTP caching, as you know, it's a service side caching. We can cache it out in terms of increase your performance in terms of the overall network round trip. And then we have other few miscellaneous policies as well, which comes under transformation, where you can do the manipulation of your HTTP address in terms of the request and the response, like where you can inject header, or you can remove certain header, as part of your transformation. And the final one is message logging. So you can very well log your messages, be it the uh, specific to request or responses. And all these API policies having a common function, that you can able to apply the API policies either for all the API resources within the API, or you can be selectively configure the API policy specific to the API resources and the methods. So these are the like kind of overall summary of out of the box policy, so which we have seen in detail in the last session. And one more thing to cover in the API policy enforcement. So ideally, how the API policy enforcement happens. So you go and apply the API policy in the API manager, but how it be communicated to the runtime manager. So for all the Mule application, the runtime manager is highly capable of recruiting all the API enforcement capabilities. So in order to get those API policy enforced at the runtime. So how it is being done is, that's why like we are using the API auto discovery. So using the API auto discovery, it whenever you deploy a new Mule application in the Mule runtime, so it goes to the API manager and gets all the policies configured for the API downloaded to the runtime itself. And once that is done, then only start the application. And whenever the transaction comes into picture, all the required API policy configured in that order will be enforced. So that's a embedded API policy enforcement happening in the Mule runtime for the Mule application. When it comes to non-Mule application, where I would say that you have a different technology of implementation, where you have exposed an API through a Java or other ESB products, but you want to have an you want to enforce API policy for that API, which is complete a non-Mule application. So in that, you have to create a API proxy. Okay, so in API proxy, you have to apply all the required API policies in order to secure or manage that. And the API proxy will again kind of a Mule application only, but it is going to sit in front of your non-Mule application. So the persons the web API clients who is going to make a call to the API, they have to go through this channel. So they have to come to the API proxy, and via the API proxy, once the API policies are enforced and every set of instructions are executed successfully, then only it will allow the traffic to the actual non-Mule applications. So we call this API proxy, which is enforcing well the API gateway. And we have another one. So when you have a non-Mule application in the Kubernetes cluster, so you have in many non-Mule application running as a container pod. And that's where we have capability which says anypoint service mesh, that is a single uh, API enforcement, API policy enforcement, which is can be installed in the Kubernetes cluster. So what happens here is, uh, it is equivalent to API proxy, but in the API proxy you will be creating more than for example, if you have 10 non-Mule applications, so then in that you're going to create 10 API proxy specific to that. But whereas in the API endpoint service mesh, you're going to use that alone to, in order to, enforce the API policies for all the non-immune applications. So it uses the, it builds on Istio, and it also, like, whenever there is a API call happens, the web API client, they have to directly reach out to the non-immune application instead of the endpoint service mesh. But the endpoint service mesh will, directly intercept those transactions and enforce API policy before the transaction gets routed to the actual non-mule applications. So these are the set of API policy enforcement we have as a capability in MuleSoft. And now we get into the actual session, what we are going to plan for seeing today. So we are going to see today on the custom policy. The reason we are taking this as a second session is, like, we wanted to show, how, because the out of the box policies are completely a kind of plug and play work, where just you're just going to configure it in API manager, a simple configuration work, and you have to disable it whenever you want. Whereas custom policy is something, you have to do a kind of coding, as the name indicates itself, right? So it's a custom made policy. So what is a custom made policy is specific to your requirement, like, what sort of policy you want to implement. Ideally, in custom policy, you can implement both functional as well as non-functional requirement, but ideally it is recommended for non-functional requirement basis. Like, for example, you have multiple set of activities you have to do before letting the request to reach the actual AP implementation. So that's where you can go with the custom policy. I will say, for example, you are getting a request from an API client, so where you want to first you want to authenticate with one of the internal API, and after that you have to re-verify with one more with an internal system, probably through connectors or through API call, whichever the case. So you cannot do this using this API policy, or you have to do it explicitly in the web API implementation. But if you want to do that particular piece of functionality for all the web API implementation, it's a redundant work that you have to go do. So that's where custom policy is kind of a reusable asset, where you can do the plug and play for all the API you need in order to do those custom made requirements. So this is a ideal definition of custom policy in general. But coming to this, what is the key factors of custom policies? We in custom policy we have two important configuration files. So one is policy configuration file, which is a YAML file, where you're going to define your parameters and metadata. So that is kind of rendered as an in a UI when you're going to apply that in the API manager. And that going to talk to the another file called implementation file. So the implementation file is a XML file. It's just that the mule configuration XML file, what you usually develop is the mule flows. And this file only becomes your deployable jar file when you're going to publish it to the exchange. And these two files are highly important in terms of for your API policy to work. And both should not work in silos. So both should be coordinated. For example, whatever the value you are defining in the configuration file, so that should be handled as a logic in the implementation file. So we will see in detail when we are going to talk about that. And also, as I mentioned, like how we are going to handle the non-functional requirement, as I mentioned, like you can do any number of checks you want to do. For example, you want to do a custom logging, or you want to do a, so when I say custom logging, I would say, like, okay, I'm getting a request. Okay, in the request I need to log only specific metadata, whereas I have to log the entire payload in the response, or I have to do certain validation in the request, or I have to do certain validation in the response. So this you can accommodate. Okay, so that as part of comes under the non-functional requirement that you can do within the custom policies. So let's first talk about the policy implementation file, which is the XML file. Okay, so ideally, this is the basic structure of your, the implementation XML file. So it starts with the root element called, HTTP policy proxy. So this is going to have, your policy name. Okay, so it will have your policy name with whatever you define with the ID, and then the proxy element should have the child element. Either it should have a source element, HTTP policy source, or HTTP policy operation. So source is the one which is going to identify that the request coming from the web API client. I will talk about what is the use of HTTP operation in the next slide. First, let's talk about the source. So under source only, you're gonna the request is going to get processed, And whatever the instruction you want to handle, within or whatever the non-functional requirement you want to handle, so you have to do that within the source block. And there's the most important factor is execute next. So this element also within the source block. But the key factor is when you say execute net, it means it lets the transaction to go out of the API policy to reach the next level. For example, if you are receiving an API request from the web API client, so it comes to the custom policy for that API. First, it does some transaction. I mean, kind of set of being executed, and then the execute next is something will allow the transaction to go to the web API implementation, do the actual processing, and once the response comes from the web API implementation, it gets it executes a remaining step that is available after the execute next. So ideally, the execute next is something which will let the mule which will actually execute the mule applications or other policy which is lying after this policy. For example, in the API policy, there are two scenarios I would talk about. For example, you have configured the custom policy as first, and also you have configured one more out of the policy and next. So what will happen is when you execute next, when this particular statement is executed, it goes from the custom policy to the second policy, which is let's say the authentication policy, I would say, and that is done. And from there, it will go to the actual web API implementation, and it does some the required processing, and the response is generated, and it comes back here. And then whatever the instruction you have defined after the execute next, so those will be executed before responding back to the web API client. So this is the ideal structure of the your implementation file XML. And you should also have a fair understanding of the execution order. So the execution order will determine, as I said, the execute next is is a key value of executing your subsequent mule applications or API policy that is available. But let's say I have two custom policies. First, I'm doing a policy authenticate, and then I'm going to do a policy log, and after that only I'm going to call the flow. Okay, so here the policy authenticate. So what I'm doing is first I'm authenticating it, and then I'm executing next, and then I'm just assign this two policy in order. So the policy authenticate is the first one, and the second custom policy log is the second one. So what happens here is when the request come from the API client, first it will do the authentication instruction, whatever See, this is just a tag I'm representing, but the instruction that you have to write it here. For example, authenticate, probably you have to call a HTTP, you have to make a HTTP call, and then you get the response of that user ID credential. So those things you have to do a coding under this. Okay, so that authentication process done. After it finds it succeeded, then it executes next. So for this executing next, the next policy that is readily available, which is policy log. So here, once it comes to the picture, what happens is it first logs the request. The first authentication is successful, and then I'm logging a request. After that, it is also doing the execution next. So when it execute next, it means the next available option is the actual mule implementation. So it goes to the mule implementation, it does some processing, and it comes back to the policy log, custom policy, not to the policy authenticate, because you have other set of instruction available here. So it log the response, and then again it goes to the policy authenticate uh, custom policy. It sees is there any other instruction available after the execute next. If it is there, it will execute it, or if it is not there, then it will end the transaction there, and the response will be sent back to the actual web API client. So you can see this is the execution of order. So this is how ideally execution will happen when you define this set of instructions. And there are other certain things you have to identify here. So you can also use the extensions of to your custom policy. So as I said, right, so custom policy is something that whatever the custom made requirements you have, you're going to write it. Okay, for that you need a transform processor, or you need a connectors like HTTP connector, or you need SAP connector. So whatever the whatever the type of mule extensions you want, or the custom policy by default support all the mule dependencies. Okay, or you want to do some HTTP policy transformation extension, so that also can be included, so as part of your form file. So using that, you can do all set of coding within your custom policy in order to meet your custom made requirements. And there is a important identification here is the outbound policies. So so currently whatever the API policies we are enforcing, it is enforcing on the inbound request. Okay, even even the out of the box policy, like all are capable of enforcing during your inbound request. So web API clients make a call to you, you are enforcing the API policy on the request and response pattern, which is acting as like middleman between your API client and the web API implementation. So what if you have a API call that your web API implementation is making to another another API? Probably your backend is an API. Okay, but you wanted to do certain set of custom requirement, like I would say, like adding some custom headers to that before making the backend API call. So how will you do that? So you have to do that using the Mule implementation itself. So you have to write the coding, but assume that this is a common functionality that you have to use it for 10 more APIs. So this is going to be redundant work for you in order to write this in the actual Mule flow itself. But if you bring that as part of your custom policy, you can very well apply that. So that takes care of doing all this custom headers mapping before making the call to the uh, actual backend. So that's where we have a tag called the HTTP policy operation. This HTTP policy operation will take care of injecting instruction before it making a call to the actual backend. Okay, so let me give you a sample like how it works on the execution order. So assume in a way you have a web API client, and then you have this MuleSoft layer, and you have a backend, and this is your web API implementation. This is your API client. So it makes a call to your runtime, so where the this is the API policy all available. So let's say assume this is a custom policy CP. So what is currently doing here is it is going to do the set of instruction before it reaches to the actual web API implementation. It's a API implementation, and this is your backend. And from the Mule implementation, you are making the HTTP call to the actual backend to get some response. And once this is done, you're going to respond back to the web API client. So assume that your particular custom policy having instruction that it is going to do some set of instruction before it allows the request to the your actual web API implementation. Let's say I'm doing the request logging. Okay, so first I'm doing the request logging. After that, I'm doing the execute next. Okay, but while executing next, what is happening here is it goes to the implementation directly, but I'm also applying the HTTP policy operation. So in that, I'm saying that map some custom address. So what happens here is the execute next will execute your mule policy, but it will before it reaches your HTTP request, which actually makes a call to a backend, right? So it injects whatever the instructions available. For example, I'm going to do some couple of custom header mapping before I'm making the call to the backend. So it will be picked up from here, and it will be enforced here, so that before it makes a call, the address will be available and the call happens, and the response will be retrieved. And once it is done, again the response comes to the custom policy. Here you're doing some response logging. So after the response logging, the call goes back to the API client. So this is the execution of order. So through this, what you can do is through the custom policy, you can also enforce the the API policy on the inbound request as well as the outbound request. So this is the execution order. And one more thing is on the error handling. So on the error handling, the we have the same options of handling the error within the API policy. So where it can have the try and error handling block, so where you can handle specifically in case of either it can have the custom error handling, or it can have a mule error handling. So that is also available within the API policy implementation XML. And one more thing is the handlebars. So what is handlebars here is it's a templating toolkit. So when I say the templating toolkit, so uh, it's ideally like, for example, I have defined the custom policy. I'm having a set of operation on the request. I have a set of operations for the response. Okay, and I would say that I want that to be kind of enabled or disabled, kind of plug and play I want to do. So sometimes I will enable the request, or sometimes I will the response. So you can even use the handlebars as equivalent as other configurations you have. So it is ideally a templating framework, kind of control your execution of instruction within the custom policy. So where you want to execute only the request instruction or the response, you can use that. So it again, it enables a checkbox, or it will enable your radio button, or it enable your expression, that whatever you want. But ideally, it's ideally checkbox we enable in terms of control execution to that. So these are the kind of a structure, I would say, or basic definition of what we have in the implementation file. uh, the second important point is configuration file in YAML. Okay, so this is the configuration file. So this is where you want to define all your property. So for example, whatever the configuration you want to see it in the UI, so you have to define this. So ideally, this is how your configuration file looks like. So you have to have the for example, you are having two different properties. One property is a kind of a text box based, where you have to fill some data, and one other one is kind of a checkbox or a radio button, because these property values are will be used within the implementation XML file. That's where using this logic. For example, if you look at this, so this is the handlebar of the before request, after request. So here you can, so these particular two different config parameters are configured in the YAML file. Okay, so the value will be taken from there. So when doing a runtime, this XML file will be executed using that values. So for example, if you enable the checkbox, then it becomes it's a it's a boolean value become a true. So then only this set of instruction will be executed. If you disable the checkbox in the UI, then this particular flag becomes a false, and this particular section will not be executed. So that's how this both all implementation file as well as your configuration file are interconnected. So these are the two essential files required for your working policy. And now, so how you can publish the custom policy? Okay, so ideally it's a four step of process. First, you have to develop a prior policy, and you have to package the policy, and then you have to upload the policy as an asset to the exchange. And then once you upload it to exchange, then you can directly apply it to the API manager. So before Mule 4, you have an option directly to upload your configuration XML and configuration YAML file directly to the API manager, and you can define the custom policy name. So you can do that way, you can in the process of Mule 3 and later, earlier. Whereas Mule 4 and later, you have to go through this process when you want to publish it online through the API manager. So how are you going to develop the API policy? So here we are going to use the Maven archetype. So Maven archetype is a you know it's a easiest way of gathering a required files for the project. So uh, this particular archetype will get you the project template for your custom policy. Okay, so when I say the project template, whatever the key file that is required. Okay, the custom policy.yaml, which is a XML configuration file, and then the template.xml, which is the implementation file. Okay, apart from that, is being a Maven project, so you will be having the pom.xml and then mule artifact.json. So by default, when you execute the Maven archetype, it will generate the skeleton structure of your project. Okay, but whatever the coding you have to do next. So that's where as part of development it comes. You have to do whatever the custom coding you want to do within the custom policy.yaml, and whatever the dependency you want to add, you have to add to the pom.xml, and whatever the configuration parameter you want to configure, you have to do it in the custom policy.yaml. So these things comes under the development of the policy. And second one is packaging the policy. So through maven you will be able to build the project, okay, and getting it as a deployable jar file within your policy folder in the, probably in a local repository. So that's your packaging of the policy. And the next important step is uploading the policy to the exchange. So while you're going to do that, uploading the policy to the exchange, so you're just going to deploy the whatever the build jar file to the exchange. And once you do that, you will be able to see the policy applied directly to the uh, apply directly to the API manager. So you can pick up the API whichever you want. You can apply the API policy. So as in when you configure it, it immediately get applied to the corresponding API. So that's how it works. So we are going to see a kind of a one use case, like how we can we'll just go through this this publishing process, like like how we can create a project, how we can do the coding, and how we can publish, and how we can test this out. So this is what we are going to do it today. And a use case is it's kind of some customer creation, I would say. So customer information will be available in the request. So as part of creating customer ID should be written back. So this is a simple use case. But as part of the custom logging, what I'm going to do is I need to ensure that I should be having a enable and disable option of whatever the instruction that I'm going to do for request and response. So that is the first requirement. And then in the request logging, I'm going to log the request attributes, not the payload. Okay, that also should be available to me, that I can also disable that or enable at any point in time for me. And in the response logging, I'm going to do a logging of a payload. Okay, so when I say the logging of payload, I'm going to log it in terms of only the payload structure, and also I should be having an option of enabling and disabling it. So this is a simple use case I'm going to talk about. So I've already created a demo, but for easy understanding perspective, I'll recreate for you guys so that you have a better understanding how it works. So before I jump on to the use case, Shubham, is there any questions in line? So I can take up.
Vijay, there was one question. Giri answered it, so you can go ahead.
Okay, very well. So let me. So first, let me explain what I'm going to do a coding. Okay, first let me copy this into a separate structure. Let me delete this. So the very first step is what we are going to do now is we are just going to develop a project. So first we have to create the project template. So how we are going to do is we are going to use Maven archetype. So whichever the Anypoint Studio workspace you have, you go to that, and you should ensure that your Maven is available, and you should be having your setting.xml config with the credentials of your Anypoint platform, so that your deployment happens successfully. So let me go to my workspace. So where it is a workspace is, this is my workspace. Let me go to that. So from here, I'm gonna initiate the Maven command. So this is the Maven archetype set of instructions. So this Maven archetype, it generates a template for you. Okay, and what are the corresponding configuration you have to do is you have to define your organization group name, the group ID. Okay, the business org ID, and then you have to define your policy name, that we can call as artifact ID. So these are the two configuration you have to do. And it will take the archetype, I mean, it will take this particular template from the MuleSoft Maven repository, and it will generate for you. So as part of generation, you would be seeing all the template required for your custom policy. Let me execute this. So when you execute it, it will ask the policy name and policy description, so that you have to feed now. So it is asking me the policy description, so I'm going to type demo custom policy. One sec. I'll close this up for now because I think already another version is running. Let me increment this version. I'm just going again. And so here I'm going to give my policy description as demo custom policy. I'm going to provide my policy name as demo hyphen custom policy. So it created the template for me. So now I have to, going to import this back to my studio. So if you look at this is the structure that has been created. You can see the pom.xml that is created for me, and then also you can see that the YAML configuration. So this is how I'm going to configure. Okay, let me close this out. Okay, it's fully built. Okay, so here you can see the pom.policy. So where you can see whatever the configuration I've given, the group ID, artifact, and everything is available. By default, it is also includes dependency that is required. Ideally, it goes with HTTP transform policy dependency. But for now, this particular dependency, it's in the enterprise repository. So, but I don't need that as part of my implementation. So I'm going to remove this dependency for now. I'll remove this property. Also you can see that other properties are built. So this is a plugin required for building your package, and this is a plugin required for deploying the package. So here you can see all the exchange related information, like how it is going to deploy to the exchange. And then also it refers to the distribution management repository information, plugin repository information, and the anypoint extension repository information. So these are the initial skeleton, the archetype builds for you, and the pom.xml. And second one is I'm gonna do the, and this is my template xml. Okay, as of now let's remove this as well. So this is the a basic structure. So now I'm going to build my code here. So I'm going to do a certain activity before executing the flow, and I'm going to do certain activity after executing the flow. So I already have the code available. Let me copy paste it. So I'll explain then. So what I'm going to do is, as soon as I get the request, I'm going to display a custom message. Okay, so the custom message is something, probably I would say that, okay, this is a demo custom policy or whatever the custom message. So so this is kind of a transaction indication that, okay, a message has received. So I'm going to display a custom message, and this custom message is something going to be configurable in the policy. Okay, and second one is as I already mentioned the use case, I have to ensure that it should be having an enable and disable option. For example, I can enable only the response action or the request action. So for that, I'm using the handlebar. So I'm using the handlebar of a request and the response action. Okay, and these values also being configured in the YAML file. So I will show you the next where it configured. So what is the actual thing I'm doing here is on the request part, I'm just validating it. Okay, so once the entire request action can is if it is enabled, then I'm executing saying that I'm creating a log message, custom log message that the request received from the user. And then the next one is I'm going to log the attributes of the request. Okay, but that is also I'm giving enabling or disabling option at the API level, so that I'm making a check here in order to do that. So if it is only available, I'm going to log it. Okay, and then the same goes for the response action. So the handlebar should be enabled in order to execute this entire block here, and also it kind of verifies the payload option. So this particular payload option also I've given in the parameter. So only if it is enabled, then only the payload of the response will be logged. So this is a very simple custom logging I'm going to do as part of this custom policy. Okay, now I am ready with my XML file, but I have to configure the configuration parameters. So what I'm going to do now is I'm just going to copy this. I go to this demo custom policy.yaml. So here you can take a look. So the first property is the request action, which is the boolean. So it becomes a checkbox for you. So only if it is enabled, the policy will consider. So you can see the handlebar check. Only if it is enabled, then this sort of instruction is executed. The same goes for response action. And then if you look at this log response payload, it will we are having a check here. It checks the log response payload. So here it refers to the variable. I'm already setting the variable at the beginning of these two parameters, and I'm just validating it before I'm doing that particular instruction. And then as I mentioned, I'm just kind of logging a custom message, right? So it is a text field, okay, or it's expression field that you can give any custom message, data view expression, or it can be a hard coded message. So whatever the value, so I'm going to log that as well. So these are the parameter I configured in the configuration. So there are two important activity I've done. One is for the the API configuration file, another one is API implementation file. Sorry, it's a custom I mean, it's the policy configuration, the policy implementation file. So both are ready, my development is done. So what is my next step? I have to package it. So how do I going to do that is I have to go to the same studio workspace. Now I get into the folder of that particular custom policy. So this is my folder. So here I'm going to run my maven command. First let's validate our build. Yeah, the build is successful. So let me package it now. So maven clean package. Build is successful. So I would be able to see the jar file created in the target folder, the demo custom policy 2.0.0 snapshot, which you could see from the form.xml file itself. So now I have to deploy this to Exchange. So how I'm going to do that is that's the next step, which is Maven deploy. Yeah, my deployment is successful. Now let us get into the Anypine platform. First, let's verify that in the Exchange. Here you can see the demo custom policy is has been updated here with the version of 2.0 snapshot. So it is available. Now let me go to the API manager. So I'm going to pick up an API which is called customer API. So it is pretty straightforward. So it is going to have customer information. In return, it is going to give me the customer ID and the message. That's all. So what I'm going to do is I'm going to apply this. I already had the previous version policy. Let me remove this. Now if you go to the customer API, you can see that add policy, where you'll be seeing all the required out of the box policy available. In that, you could be seeing the custom as well. So you click this custom policy, click next. Now you'll be seeing this, whatever the parameters we configured. So so when I enable this, it means the request operation will be executed. If I disable it, none of the request operation will be executed. The same goes for this one, the response operation. So I have enabled both this thing. Okay, so request as well response operation will be executed, and I'm enabling log the response payload in the response operation, log the request address in the request operation, and this is a custom message. So let me change the custom message. I'm going to apply this. Now the policy is applied. So let me run the API.
Hey Vijay, we have some questions. Do you want to take them up right
Yeah,
away? Okay. So we have one question from Naveen, like how we can apply resource level policies like get post. If possible, kindly show me.
yeah, sure. So when you apply a policy, let me show you its configuration. There's advanced options. Okay, here you can see that. Okay, apply config. So by default, it is applied to all the API, all the HTTP methods and the resource, on the particular API. Here you can be, selecting that. You can mention which particular, for example, I want to select for post, right? I can tell the, the URI of that. So this is how you can, selectively apply this policy to the particular HTTP resources. Does that answer your question?
Okay, let him respond if this answers your question, Naveen. Uh, we have second question from, yeah, Sagnik. So I think he mentioned two questions, like what is the policy evaluation order between custom and out of the box policies? Can we execute an out of the box policy, then a custom policy, and then again an out of the box policy?
Yeah, yeah. See, when you apply the set of policy in the API, right? So whatever the order you are applying, that's the order it takes, as a precedence, when it during the runtime.
Right? Can such an example be shown for reference?
So for example, I'm gonna add. Okay, let me add one. Let me add one rate limiting here. So I'm gonna say 100 requests time 1 minute. So I'm gonna accept 100 requests per minute. I'm gonna apply this. So this is how it works. So first the custom policies get executed, and even how it works is the custom policy request part get executed. Okay, and then the rate limiting is executed, and then it goes to the actual flow implementation. The response comes back, and the response comes back to the custom policy again. The response instructions get executed before responding back to the API client. Is it clear?
You can enable your mic if you have any doubt.
Yeah, yeah, yeah. Thanks for that explanation, Vijay. So I also had another question. If you can take that as well.
Yep.
Yeah, so his second question is like, how does execute next understand which policy slash flows to execute next? Where do we refer that next policy to be executed in the policy implementation file?
Yeah, see, the execute next, by default takes the precedence of configuration, whatever you have. As I mentioned here, it takes the order from here. Okay. For example, if you have only one custom policy, then it's pretty straightforward. It goes to the flow implementation. Okay. For example, if you have two or three custom two or three probably out of the box policy you applied in an order, it goes through the chain of commands before going to the flow implementation.
Yeah, so execute next takes whatever is present over here and does not
Yep.
do anything on its own. Okay. So the other question is like, so in the demo custom policy, you have this execute next, right? So maybe in the flow that it is going to, the API implementation flow actually has two flows. So how would execute next understand which among those two flows to execute first?
See, we are talking about the HTTP resources, right? So
Mm-hmm.
so the thing is, it goes to the HTTP listener. Okay.
The
So
HTTP listener listens maybe on two separate paths. Like I have two HTTP listeners listening on path A, path B. How does execute next know which path to go first, path A or path B? Where do we mention that?
see, it is pretty okay. Everything runs within your runtime. Okay.
Mm-hmm.
So uh, first of all, you have a listener, right? So the listener, I think for single API you will not be having more than one listener, right? Probably you are going to, are you saying that you are going to have a different port for the listener?
Right, right, yes.
Yeah. See, that indicates your API, that information is already available in your API request. So that routing of this specific to the particular API implementation. For example, you have 8081 as a port and 8082 as a port, right? And the API client is making a call to an 8081. So the runtime having a capability to identify that, it has to go to 8081. So when it comes to that, right? So that's where the API policy enforced. And when it says execute next, it is having the requested information, like where it come, where the information has to go to.
Got it, got it. So I thought execute next does some overriding on its part, but I don't think so. It does something like that, right?
Yes,
Got it. Thank you.
I think it is applied. I think the API is running. Let me clear this one. So let me trigger a request. Yeah, I got the response. So let's check that the custom logging is working here. So when I did that, the very first important is, I've mentioned that I need a custom message. So custom message is logged. So welcome to my MuleSoft Meetup group. So we will validate by checking our code as well. So the very first in the logging is, I'm doing a custom log. So that is listed, and then I have enabled the request action. So what I'm going to do is, I'm once it is enabled, I'm just giving another indication that request received from the user. So I should be seeing this here, the request received from the user. And the next one is, I'm going to log the attributes of the entire request. So here you can see what is my local address, where it coming from, and all the remote address, everything is available with the class, the HTTP address, query parameters, everything. And after that, what I'm going to do is, I'm checking the response. So it goes to the API implementation. It does the processing, and the response is coming. Now the response action comes into picture. So it is also enabled in the policy, where I'm doing the response to the user. So which you can see it here, response to the user, and I'm logging my payload. Whatever the payload I have listed out here, as you can see it now. See, this is a very simple use case, for your understanding. But when we are going for custom policy, there are a lot of actual implementation. Like we would be making direct calls to the connectors, probably API calls, or you can even talk to a DB, or you can talk to any other systems from the custom policy by adding a, let us say, dependency. It depends on it is just a simple custom policy to give you a fair idea that what is the real use case of custom policy, and what you can do with that, and how to create a custom policy. So that is a pure mode of this session. Yeah, I think I'm done with this session for the day, and I can take up the questions if anything is there.
So far, we don't have any question in the chat.
Yeah, one query, Vijay. Thank you for the session. Is there any way we can control the spike on outgoing traffic for a specific URL, like TPM to the end system?
See, control the traffic, well, I mean, okay, outbound policies, right? Yeah, we can do see, one more use case I'm even trying. Okay, whereas, like, applying the out of the box policy from the custom policy itself, okay, which I'm trying to do that. uh, where we are using this HTTP operation, right? To, for example, I want to apply the rate limiting, or I want to apply a kind of an authentication, or any kind of transformation. Okay, uh, I heard there's a use case we can do, but currently I don't have an answer for that.
Thank you, Vijay.
Hello.
Yep. Does anyone have any questions? Like, you can ask in the chat, or even you can unmute your mic and feel free to ask.
Yeah, Vijay, I had another question. I'm a bit
Yeah.
confused with the execute next actually.
Yes. Tell me.
So I was wondering, if I don't mention that execute next and I have a policy following that custom policy in the API manager, would that policy still be executed or not be executed at all?
Will not be executed, because these are the default essential elements that should be presented, uh, like, when you're creating API policy. So when I created this project, right, through the Maven architect, so default parameters that were available were, like, the the API policy proxy, API source, and then execute. So these three elements should be presented, because execute next is the one you are letting the control to go from the API policy and all the way to your API implementation.
Okay, got it, got it. Thank you so lot, Vijay.
No issues.
Yeah, Vijay, maybe a suggestion for the next meetup. Like,
Yeah.
suppose we're reading a 1 million records, but let's say we're doing the batch and processing to the queue and to the sending it to the system layer. But we want to control the traffic to the end system, like by applying max concurrency or the max local message. So basically, if you want to send a 2K TPM or 3K TPM, how can we tune that?
Okay. Can you rephrase your recommend again? So you're going to do the asynchronous implementation as a batch, and you're going to process around 1 million. So what is your source?
Source can be a file or a database.
Okay, fine. So you're going to take, let's say, you're going to take 10,000 records from the database, and then,
I mean, 10,000, maybe a million.
okay,
Like,
fine, million.
but the end system have a limit of 2K per TPM or 3K TPM. So how do we tune that basically?
Okay. See, with respect to that, right? You have to consider the. I mean, I know what your points you are getting to the policy level. Okay. Yeah, but this particular design, you have to consider the API capability as well. Okay. When you are going to hold the thread of an API for a very longer time, okay, uh, that is not kind of recommendable in terms of the reliable implementation when you're doing an asynchronous mode. For example, you're going to process 1 million record. I understand there is uh, a constraint in the backend, so you want to create a latency. Okay, so you don't want to shoot all the 1 million record to the backend, but you want to do in a phased manner, like 2000 record per minute, right? Is that a way you
Right.
want?
Right.
Yeah.
Yes, yes.
So
So
yeah.
that I can pile up in the queue, but from the queue, I want to tune it.
Yeah. So see, with respect to the policy level, right? You wanted to, you wanted to have a policy to,
No,
do the
no,
queuing.
no, Vijay. Maybe I'm not talking about the policy. Suppose if we apply policy, right? Like it may be in the waiting state, but I want to like take 2K per minute from the queue. That's my intention.
Okay, so
Maybe the
let,
subscriber level, we have options
and
like
when you
max message, max
and
concurrency at the flow level, right?
okay, and when you say queue, right, are you using any point MQ or the VMQ?
Yes, any point MQ.
Okay. See, ideal implementations here is, instead of going for the policy, right? So you can, meticulously control that, from the policy. For example, uh, I would say, let's say you're taking 1 million messages from the database. Are you splitting as a single message and putting
Yes,
1
yes.
million message to a queue?
Yeah.
Yeah.
Okay.
Because
Okay.
the end system may not support the array format.
Understood.
One object, the one call.
Understood.
So
Mm,
like now we are controlling using the subscriber flow, max concurrency, and max local message. But
understood.
like we are achieving it some extent, but not exactly.
But for this scenario, I pretty
I
much
heard
doubt
that
that.
the queue can support. The normal queue can support 30 TPS, and the other queue supports 16 TPS. Basically,
Okay. Okay, so my point is, you want to know the best
yeah.
implementation guidelines there, or you want to know how to apply policies to that. Maybe I want to get your correct question on
May
this.
not be the policy. No, I mean not policy. Just I want to tune it. Uh,
Okay,
suppose one client requires 2K TPM, another client requires 3K TPM. So that with the configuration, I need to control that. Basically.
okay. Yeah, this is something I will work it out.
Sure,
May I know
sure,
your
sure.
name?
Srinivas.
Okay, this is something I'll work it out. I know, as because I'm having a plan of taking sessions related to, best integration patterns. So I will
Okay.
include that as well.
Yeah, yeah, sure, sure.
And
Thank you.
anybody in the session who has some answer can answer it.
Why don't we use pagination module for that in the implementation part?
I mean, I cannot hold the database for a long time.
See, actually, you're not even holding the database, right? So you get all
Yes,
the
yes.
1 million
Yeah,
record.
yeah,
You're
yeah.
going to put that as an individual message to the queue. Now
Right.
the fact here is, it is going to, process message by message. So each message is, individual transaction.
Yes, yes.
But one problem here is, when you're going as an individual transaction, right? So that in that case, you don't have a, control over, fine tuning, or regulating the traffic to the backend layer.
I mean, now we are trying to do that with the max local message setting of the subscriber, anypoint MQ, and
Okay.
the max concurrency of the flow, which is listening to that queue, basically the where
Okay, using
listener
that. Okay.
exists. Yeah, yeah. So like we have put something like max concurrency 2 and the maximal local message 25. Now we are like controlling 3K TPM.
Okay, so that's an interesting requirement. Okay, I'll work it on this.
Yeah, because that's the NFR from the end system. Yeah.
Understood. Any other questions from anyone?
Vijay, we have one question from Amber. Like, we can do logging directly in MuleFlow. Why are we using custom policy?
Okay, see, this is, for use case scenario, just to give you a, hint of, what you can do with the custom policy. Any requirement you can fill in with this.
Right. If anyone has any more questions, feel free to ask. I don't think we have any more questions.
Yeah, then we can wind up the call.
All right, Giri, you there? Like, you can. Yeah.
Yeah, yeah. Thank you, Vijay, for your time and effort for bringing this insightful session to the community.
Yeah, thanks, Giri.
Not only that, it's highly informative and engaging as well. I could see it's very interactive. Your demo as well as
Yep,
executed with clear explanations as well.
yep. Actually, we are getting more topics for the next sessions.
Yes. So
May I know
thank
who's the
you,
person asked this question? I mean, I forgot the name.
Srinivas.
Srinivas.
Yep.
Srinivas. Okay.
So thank you all. So I would like to remind one thing that about feedback. So please put your feedback, submit your feedback form, so that that your ideas and opinions are very important to us, and it will help us to enhance our future events as well, and we'll ensure we deliver the information that matters to most of us.
Yeah. So feel free to drop any type of feedback, okay, for topic, that new topic that you want us to present, or any other way that you want us to improve our presentation. Feel free to drop us.
Related to the topic which you are expecting, or if you want us to correct something, anything.
Yeah, we are happy to take that.
Yes. And if you want to become a speaker in Mysore group, please reach out to me or Shubham. We'll help you.
Yeah, maybe the next task, Vijay. Like now we are applying policies on a sequence